Hello. So the next thing to discuss about the models with several independent variables is collinearity. So there is something called exact collinearity, and it occurs when there is a precise linear relationship between two or more independent variables. So basically it occurs when sum of two or more independent variables is constant. I can give you some examples of exact collinearity. So first of all, it can be proportion of males and females in population. The sum of these variables will be always equal to 100. So you should use only one of those variables, either proportion of male or female population. Number of hours devoted to sleep, work, and leisure. The sum will be always equal to 24 hours, so you can add only 2 out of those 3 variables. And finally, dummy for male workers and female workers. So if you insert 2 separate variables, one of them takes value 1 if the worker is female and 0 if the worker is male, and the second one takes the value of 1 if the worker is male and 0 when the worker is female, then the sum of these variables will be always equal to 1, because respondent will be either male or female. And then suddenly I realized that this example is not politically correct because I did not account for non-binary people, but nevertheless you've got the idea, yeah? Okay. So there is a difference, however, between collinearity and exact collinearity. Collinearity is linear collinearity. It's about the exact linear relationship between those variables. However, some variables can be correlated, at least to some extent, as long as there is no perfect collinearity. You can do something like this in GRETL. So first of all, here you can find the formula for calculating the correlation coefficients between two variables. And I will show you how to actually perform this kind of analysis in GRETL. So for this purpose, I used, I think I used neoclassical model of growth dataset. So give me a moment, I will just show you how this can be done. Okay, so now we have the appropriate dataset. In my case, GDP per capita standard for the dependent variable or GDP per capita growth. Okay, it does not really matter. So let's concentrate only on those variables. So you do it in this way. You do correlation matrix, ensure uniform sample size. So basically for some of those variables, some data is missing, and uniform sample size means that we exclude all the observations when those variables are missing. Okay, so this is the result. The same result you have on this slide. So basically it's just correlation coefficient between those two variables. As we discussed during the very first lecture, correlation treats variables symmetrically. So we just analyze to what degree those variables tend to move together. There is no general criteria for high or low correlation. This is something you have to keep in mind. But the rule of thumb says that if correlation coefficient is higher than 0.5, it's something significant, and this is something you have to take into account. So for instance, in our case, we can see that the correlation coefficient between literacy rate and natural resources rent is negative, which means that higher literacy rate means smaller natural resources rent and vice versa. Actually, there is a significant correlation between the rate of secondary education, to be more precise, secondary education enrollment rate, and literacy rate. It's 0.91, which makes a lot of sense. Analogously, give me a second. Yes, there is for some reason negative correlation between secondary and tertiary education, and so on and so forth. So this is how you interpret this. If it's positive, variables tend to move together in the same direction. If it's negative, then variables move in the different directions. So correlation itself does not tell you anything about collinearity. Please keep this in mind. So nevertheless, analysis of correlation coefficients is one of the very useful pre-estimation practices, analogously to testing your data for normality. It just allows you to indicate some potential problems in your regression model. However, if you want to check for collinearity, you have to do something different. I will show you. Again, you go to GRETL, you highlight the variables you would like to analyze, you push collinearity, and ta-dam! So this is the output of Belsley-Ku-Welsh collinearity test. And what you're interested is several final lines of this test. So in my case, I just skipped some of the variables, but on this slide, I included the full range of variables. So we can see that actually there is some collinearity in case of those two variables, literacy rate and secondary education. And again, if we go to the previous slide, when we analyze correlation coefficients, you can see that those two variables had the highest correlation coefficient. So according to the results of this test, you cannot include both of those variables to the regression model simultaneously. We will get back to this when we discuss the full set of assumptions you use in order to verify whether your regression model is good enough, and the absence of collinearity is one of them. So collinearity is not good for your regression model. It biases the output. So according to the results of this test, I am not allowed to include both of those variables to the regression model at the same time. I can either use literacy rate, either secondary education rate. Of course, you can do two regression models with so one model per each variable. So basically, it's up to you. Or for instance, you can verify which of the variables has more observations and stick to this variable. But again, do not include both of them simultaneously to the same regression model. Okay, so that was it when it comes to collinearity and testing for collinearity. I hope you enjoyed this video and see you in the next one.